Welcome to Activity 3.1, Investigating the Connection Between Elevation and Energy. If you are watching this video, you probably were absent or for some reason you weren't in class, which I guess means you were absent for Activity 3.1. And so you are completing this online. So what we're going to do, we're going to use cans and balls of clay again to explore the relationship between elevation and energy. So if we remember back to some of the earlier investigations, one, we dropped a large can at 30 centimeters and then we pushed it down. Now we kept the same mass because we wanted to increase the speed. In another experiment, we dropped a large can from 30 centimeters and then we dropped a small can from 30 centimeters. So the distance was always the same, 30 centimeters. What we're going to do now is we're going to drop a can from a higher height and a lower height or lower elevation. So what I want you to do is make a prediction. How will dropping a can from a higher or a lower elevation affect the impact it has on a clay ball? Explain your ideas. So pause the video briefly and then go ahead and answer this question or make this prediction. All right, now that you had a chance to make your prediction, what's your prediction for this one? What is the relationship between elevation and energy? Think about the same can dropped from different heights. Now, I'm going to give you a little bit of a hint. If you look up at top of the video now, it says gravitational energy. So when they talk about energy, really, what is the relationship between elevation or drop height and gravitational energy? So what do you think that relationship is? Go ahead, pause the video, and in just a sentence, what is the relationship between the two? Thank you for making that prediction. Now what we're going to do is you're not actually going to do the experiment because it's a video. So how do you drop a can via a video? So what we did is I'm going to move forward, and what I did was I took data for you. So here's the data table that you needed to fill out. There's no line in here, which is good because there probably shouldn't be a line here. And your book's going to look more like this. So the first thing I'd like you to do is I'd like you to copy down this data. So the T0, this is the thickness of the Play-Doh ball. And what I did was I measured in centimeters. So you can put 3 for all of those. Then what I did was I dropped the Play-Doh ball. And instead of just measuring it with a toothpick right in the middle, we actually measured it with 3 toothpicks. One on one side, one in the middle, one on the other side. So the left side, the middle, and the right side. And what that does is it gives us a better average. So toothpick 1 was 2.9, toothpick 2 was 2.7, toothpick 3 was 2.8. So go ahead and record all the data. So the top lines right here are for 10 centimeters. So we did 2 trials at 10 centimeters. So here's the first trial, here's the second trial. Now what we did then was we raised it up to 20 centimeters. Remember earlier we did experiments where we always kept it at 30 centimeters. Now we're actually changing the drop height. So when we did it at 20 centimeters, I had 2.7, 2.5, and 2.5. And then for the second trial, 2.6, 2.5, and 2.4. Now in this next column, I guess it's not the second column, but in the next column, we have to find the averages. So all I did was took toothpick 1, toothpick 2, toothpick 3, I added them all together, and I divided by 3. And I got this number, 2.8. So go ahead and record your results for the data that I've given you right here. So once you have that data, and again, if you need to pause the video to catch up and record all of your information, you can. Now the next column was the thickness change. What we did with this was we took T0, which was 3, and we subtracted the 2.8 and got the average thickness. So it was 0.2 for the first trial at 10 centimeters. Then it was 0.17 for the second trial at 10 centimeters. Then it was 0.43 for the first trial at 20 centimeters, and then 0.5 for the second trial at 20 centimeters. Then what we were supposed to do in the last column is we were supposed to find the average thickness change. So all I did was take 0.2 and 0.19, and then I divided them. And I did round. This is why the number is 0.197, because I did round to the nearest hundredth spot. And then for 0.43 and 0.5, I came up with 0.47 centimeters. Again, I rounded to the nearest hundredth spot. So now that you have this data recorded, what I'd like you to do is I'd like you to answer these questions. What are the advantages of calculating an average value when doing an experiment? Go ahead, pause the video and answer this question, please. Number 2, from which dropping height was the average thickness changed the most? So when you're answering this, which drop height? 20 centimeters or 10 centimeters? So which one was the average thickness changed the most? And even though it doesn't say why do you think it changed the most? Go ahead, pause the video and answer this question. Thank you. Number 3, what can you conclude about the relation between height and energy? Remember, when we talk about height and energy, the energy is gravitational energy. So what can you conclude about the relationship between them? So if you raise the can up higher, was there more energy or less energy? When the can was lower, was there more gravitational energy or less gravitational energy? Go ahead, pause the video and answer that question, please. Now the follow-up questions. Number 4, your group used an object with fixed mass. And in this, we actually used a heavy can, which was 425 grams. How will the results be different for an object with a different mass? So how will the results change, say, if we used a can instead of 125 grams or 425 grams? What would happen if we used one, say, had 600 grams or 800 grams or 1,000 grams? Or what would happen if we used a smaller can, the lighter can? How will the results be different for an object with a different mass? Go ahead, pause the video and please answer this question. And finally, number 5, in Activity 2.2, you found a relationship between speed and energy. And if we remember what that relationship is, if you increase the speed, you increase the energy as long as mass stays the same. What is the relationship between the speed of impact, in other words, how fast that can is going when it hits the Play-Doh, and the dropping height? What is the relationship between the two? Go ahead and please answer that question. You can pause the video. Thank you for completing activity 3.1. Again, when you get finished with this video, please show your teacher. That way your teacher will know that you've finished the activity. And then if you want to go over these questions with your teacher, that way you can find out if you're correct, if you're not correct, and that way if there's any misconception, you'll get those worked out before the test. Thanks.